Okay, welcome to Module 2. So this session is about delving further into those kinetic energy thresholds for different crash types at intersections. And then doing the same at mid-block locations. So a mid-block is a term that just means between intersections. So we're going to look into that kinetic energy. And then we're going to look at characteristics of these road environments that align highly with safe system principles or don't so much. It's been really good session last time, sort of at that philosophical level, talking about the safe system. What is it? Why are we doing this? And how do all these elements fit together? And what are the principles? And starting to delve into the application of that in the real world. And we're going to, I suppose, go further into that. We're going to spend most of this session talking about the infrastructure design and choices we make with the physical infrastructure. Now, it's an interesting sort of time with independent assessments of transport projects in New Zealand. So road safety audits have been around for quite a while. I'm just trying to think, in New Zealand, 25, 30 years almost. And they're pretty well known, pretty well respected as an independent assessment of a transport project to try to ensure safety. Design reviews are commonplace as well. So if somebody is designing up a new intersection, new shared park facility, whatever it is, you would expect there to be a design review process where somebody who is not the designer would review the design, but sort of common practice there, check calculations and check logic and those sorts of things. Safe system assessments then came along and they sort of overlapped road safety audits a lot and a little bit of design review in there. Then there's sort of safety in design, which is thinking about, well, can whatever we want to create be built safely, be maintained safely, be decommissioned safely even. And then there's some sort of possibility of a check that all road users of all abilities will be able to use these facilities that we are creating, whether they be in a wheelchair or vision impaired or the like. So there's this sort of mess of different things going on there. And Waka Qatar here, as I mentioned, has released the Safe System Audit Guidelines, which essentially takes these two and puts them into one document. So we're starting to get this consolidation of these items. I'm also sort of doing a bit of work in New Zealand and working with others. And the expectation is that a bit more of this DDA style check, and I use the term DDA, that stands for Disability Discrimination Act. Now, there is no act in New Zealand that mandates specifically any of this in the same way a lot of other jurisdictions do, and they have it in a code and standard and the like. But common practice is that this safe system audit or road safety audit does take a bit more of that burden. So anyway, I was just setting a bit of context there. Happy to sort of answer questions and clarify things as we go, but I'm still going to be running through this safe system assessment process here. The first thing is to really delve into, well, what makes something align highly with safe system principles when we're thinking about the infrastructure, the design, the operations, the management. And let's start by looking at intersections. So intersections are a spot on the network where risk does spike. Okay, so you'll see if you look at any sort of risk mapping of a network, any sort of, so there's like, I was going to use some of the acronyms for risk assessment methodologies for infrastructure of a network. So there's IRR, which is infrastructure risk rating. There's ANRAM and Kiwi RAP, and there's a lot of them. But anyway, net risk. If you look at a length of road, and it doesn't really matter if it's a rural length of road or an urban length of road, you sort of will see risk, and it'll have some level of risk, and then it'll have spikes. And the spikes will be the intersections. That's not a great diagram, but that's kind of what it's going to look like. And the intersections are an interesting spike in risk for a number of reasons. Well, first of all, you do have that obvious vehicle-to-vehicle conflict potential, and you see the picture on the screen there of vehicle-to-vehicle conflict. You have a point where then you've got pedestrians crossing, cyclists crossing, people wanting to turn. So I use the term turbulence. There's a lot of turbulence at an intersection. Then you have this interesting thing where you put a lot of roadside hazards around intersections, or it is done. Signal pedestals, light posts, well, if you've got power lines and you need to turn them around a corner, you've got to put a pole there, don't you? So you end up with a lot of physical infrastructure around this. And what we see is because of that turbulence, vehicles will avoid, and we see runoff road crashes increase at intersections as well. So vehicles leaving the road and lots of fixed hazards. So it's kind of a fairly nasty mix. So Monash University Accident Research Centre at one point came up with these very sort of high-level principles of what would make an intersection, well, when you're thinking about intersections, what would be better aligned with safe system principles? And you can see there they've got fewer vehicles and fewer intersections. Now, they're pretty high-level sort of strategic planning style ways to think about it, but that's kind of nice and neat, because it's, we can get big wholesale change if we look at those fewer vehicles, fewer intersections. But if you remember back to what we were talking about just at the end of the last session, we talked about exposure times likelihood times severity, didn't we? That was our risk formula: exposure and likelihood and severity. Those are about exposure. It's about really less vehicles or less areas where vehicles can have that intersection conflict. Fewer conflict points per vehicle, that's a likelihood factor, right? Because the intersection's still there, there's still road users going through it. It's just less complicated, there's less turbulence, there's less points where they can crash. And so the likelihood of a crash comes down. Then we get into all of the severity aspects. And we're talking about those speeds and angles that we talked a little bit about with those graphs. So we're thinking right angle crash, we want them to be out 50 kilometers per hour or below for passenger vehicle crashes. Where you can get more angle on that, all right? Where we can get more angle on that, let me draw a little vector diagram, take you back to your year 10 physics or year 11 physics. Now, you've got a certain energy that goes into the environment in that sort of crash. But when you put more angle on it, more of the energy goes into the environment. You sort of bounce off, don't you? And so this has more energy transfer to the occupants of the vehicle than this. So if we're able to get a bit more angle on our crashes, from that perspective, we can have that crash at higher speed. When we get into having vulnerable road users crossing and involved, we're talking about not exceeding 30 kilometers per hour, but really we want to be lower than that, okay? Where we've got that pedestrian conflict. And I'll next module, I'll talk a bit more about some context around that and where in our transport planning, we would be thinking about these lower speed environments and how you could design a high speed environment to be safe or a low speed environment. It just has implications on the functioning of your city or your region or the like. Now, if you can't get these, we're saying that we need to fundamentally change the setup. So you can operate intersections at quite high speed, passenger vehicle to passenger vehicle, with high alignment with safe system principles. But you just need to do it so that the relative change in speed is not as great. So let me just show you like on ramp or big acceleration lane. Okay, this can happen at 100 kilometers per hour when these crashes happen. But the delta V, the change in velocity, is very, very small. Now, certainly you want to think about what happens afterwards, run off road and all of that. But in terms of that, the initial crash, the forces and the transfer of energy is very within tolerable limits. And that gives us good opportunity to continue to operate our high movement for passenger vehicle or freight routes in a safe way. So that's all quite theoretical, really. I've got some more figures here for you. So when we talk about 90-degree angle crashes, 90-degree angle crashes, 50 kilometer per hour or less. When you get more angle on it, that's where we can go sort of up to 60 is about the limit. Head on and rear end, we put in that 70. They're just broad brush sort of speed angle passenger vehicle categorizations. So when you're looking at designs or you're looking at existing intersections, you can have a look at the angles you think crashes will happen at. Now, you don't need to be this precise, but if you're in CAD, you can do this very easily, but you don't need to do that. You can look and go, well, I'm just going to change color here. Well, a vehicle coming out here and a vehicle coming there, that's about a 90-degree crash, isn't it? So we think about that for 50 kilometers per hour or less. Okay, it might be 104, but really, realistically, 90 is close enough. And this one, they're going to be out, they're going to be turning. We can think about that. We can probably go to 60 on that or below. So you're starting to look at conflict and think about speeds, and it gives you that relative point. You think about the secondary crashes and the run-off road crashes around intersections. Here's some research done by the Centre for Automotive Safety Research out of the University of Adelaide, where they looked at secondary crashes which resulted in death or serious injury. So something had occurred at the intersection where vehicles had collided. Now, it could have been direct impacts like this, but it could have also been vehicles clipping, avoiding, and just clipping the end of vehicles and the like. But then they replotted that onto same axes. So you've got vehicle down here, you've got vehicle down there. They come in, they crash, and of course the bulk of crashes go out there. Do we need a lot of expensive research to know that? No, we didn't, but it's there for us if we do know. There's a few interesting ones spinning off and going into those areas, but it's fairly obvious, I think. Okay, enough of me talking. Well, I'll do a little bit of explanation into this exercise I'm going to get you to do. I'm going to give you a little bit of time to have a think about this, but let me introduce it, and then you're going to do some thinking and come up with some ideas. Here we go. We've got an intersection. This major, well, it's a state route. It's 70 km/h speed zone, and it carries about 21,000 vehicles a day at about 12% CB, heavy vehicles or commercial vehicles. Okay, so it's pretty decent state highway. This side road has a 50 km/h speed limit. It has about 2,000 vehicles a day. The school down here. What else can I tell you? That's a bus stop there. It's a shared user path. This is like the culvert drain. Water goes in there and comes out there. What else can I tell you? Up the road, about 500, 700 meters, maybe a little bit more, is a set of traffic signals. And there's another set of traffic signals about 2 kilometers down this way, or maybe 1,800 meters. More signals down there. Yeah, I think that's pretty good. Let me show you it from ground level. So there you go. You can see it operating. Vehicles. There's our bus stop. Got lighting. Got this little service road thing going on here, which is a two-way service road. Have a look from the other direction. There you go. There's your shared use path over there. Shared user path. That's that drainage culvert-like thing. So your task is to remove fatal and serious injury crashes at this location. Going forward, we don't want any more ever at this location. But you've got a budget constraint. I'm going to give you 3.5 million because I like you. I'm upping the budget. What do you reckon, Kathy? 3.5? That'll do. 3.5 million. You can't close the intersection. I know you're thinking about those principles. Okay, we'll eliminate the intersection. That will work. We've done the consultation. We can't do that. And you're operating in the current political, organizational framework that you're in. So if you said we're going to reduce the speed limit and enforce it at 10 km/h on the state highway, I think we might be pushing things a little bit too far. I don't think we'd get that approved. If you're going to go down that track, I want some justification on how you're going to get that approved by your the road authority and the directors and everybody that would be required in that approval process. So I want you to come up with changes to this environment, and I want you to categorize those. And this is the one of the really important points here is to categorize. So if you say something like, I don't know, improve lighting, which would be weird because you haven't seen it at night and it's got lights there already. But if you said improved lighting, then you would just put an L at the end of that, L for likelihood. Because we know if you improve the lighting, it lessens the likelihood of crashes. It does not change the exposure to crashes. It does not change the severity of the crashes. It just makes them less likely to happen because people can see what's going on. Okay, so there's an example of how you do that. So come up with your ideas, categorize each of them. So if you have multiple things you're changing, each thing should be categorized. Oh, that's an exposure, that's a likelihood, that's a likelihood and severity. And yeah, if you don't know what things would cost, which is very understandable, I will be your instant cost estimator tool. So you can just simply put anything you want to know the cost of. You just type it into the chat and just write, whatever it is. So, maybe grade separation, like flyover cost. And I'll come back and I'll say $37 million. You can't afford it. But, you can put anything in and I'll cost it straight away. And what have I missed, Kathy? Anything in explaining this?
No, I think you've covered it all quite well. You've already told us what's out of budget, but I'll kick us off with some costs. What would a roundabout cost?
Oh, good. Right. Okay. A roundabout to meet the Australia's Guide to Road Design part 4B, 4A, 4B, 4B. Would cost you $7.9 million.
Okay. So that's out of budget. So quite a few people were on the roundabout. Let's do the roundabout. What about signals? What about signalising the intersection?
Signals, signalising will cost $2.95 million. It's got a good setup for signals in the physical infrastructure.
Okay, so
not a huge amount of civil works required.
Signalising looks like it's in budget. So we got a cost for that one. Hold on. What else have we got? Oh, everybody jumped in with people are keen. They don't need time. They're jumping in with suggestions, which is fantastic. And people are putting in the exposure, likelihood, or severity, which is also fantastic. You said you can't close it, but can you remove the right turn movement?
So we have to access this from both directions and get out both directions. Now, there's not great U-turn spots in either direction. So if you left in, left out it, it's a very sort of significant project to change that. In fact, just the associated works to make proper functioning U-turn facilities within reasonable range sort of spends your whole budget.
Okay. So you're saying no to that. Tell us about an underpass, whether it be a cycle underpass or a pedestrian underpass.
Okay. So to build a new underpass in its own right, well, that will be $4 million.
Okay. What about the I can't point to it on the screen. Yes, thank you, Darren. You're providing the words that I'm looking to use. Can you convert dual use the drainage channel to include shared path? Price for you, Darren. Yes.
I like that, but yeah, it's a bit hard to see on this. I love the idea.
Okay.
You do need to spend a couple of $1 million to do that, because you need to make it deeper and cut out a little bit of the median to open up some light and ventilation and things. But yes, you can do that within budget.
Tell us about, somebody has mentioned Seagull intersection. Yeah. Tell us about that.
What would you like me to tell you? How much did it cost?
A little bit, yeah. And what should we tell people what a seagull is?
Yeah.
Or does
sure.
everybody knows? Maybe if you give me
I
a
don't know.
thumb.
New Zealanders do seagulls.
They love a
bit.
seagull.
They don't mind a seagull, but I'll just draw a little seagull on here to show people what that is. And then you have
Apparently New Zealanders have made the seagulls extinct now.
that and the dodo, eh? Yeah. Well, seagulls are an interesting one. I will talk to that actually. Maybe after we give people a little bit of time.
All right, fair enough. Okay.
Because it's an interesting.
Yes. Now the other one, just yell out to me if I haven't done lots of great ideas coming in. And I think I've covered all the raise platform cost. Here we go. Another cost.
Raise platform on each of the approaches. So that package of works would be 500,000.
Bargain.
Bit of drainage works and civil works and some surfacing.
And I think you talked about an overpass, pedestrian overbridge. Was that your 37?
No, that was a full grade separation of the road. Pedestrian overpass. Well, we can do that for 5 million.
5. Okay. Jacques suggests it's conveniently priced for a combo with signals. Is it?
Interesting. What do we say for signals?
2.95, I think you said.
Oh, right. And 500,000 for some raised. Yeah. Wow, geez. Let's give everybody one more minute, Kathy, and then I'm going to start talking through some of these.
It's disappeared. All right, everybody's got one more minute to have a think about it. Very good. Love it.
Sorry, I'm back now.
I don't think you need to be sorry.
Well, Kathy, I must say I do like this group. They have come up with some excellent ideas. I'll give them a little bit more time, and then I'm going to talk to some of these ideas. I do like the fact that people are putting in their exposure or likelihood or severity. I think we need to get people a little bit more clarity in their mind on those, but that's okay because that's what this session is going to be a lot about. And that's what, in fact, the assignment at the end of this session is going to be about. So you're going to get lots of practice at that. Okay. So we had a good discussion between roundabouts and signals at the start there. And we saw people all over the place saying whether that would influence likelihood or severity or exposure. So we've got a bit of everything. Yeah, so we've got the lot. So I'll talk to that shortly. But it's an interesting sort of debate. I mean, people immediately sort of went to that, these different options. We had the seagull, which was an interesting one that came in, and I've still got it sort of drawn on there. Now, seagull intersections, they're quite fascinating. So when you think about a seagull in terms of crash angles, right, they're quite friendly on that part, right? You've still got pretty much a right angle crash there, so that's not good. Got pretty much a right angle crash there, so that's not good. You also have a merge from the right going on. So while the crashes that happen are lower transfer of kinetic energy, the chance of them happening is higher because it's an awkward move to merge from the right. If you're in an articulated vehicle, like a truck with a cab, you can't do a head check because you'd be looking straight at your cabin, so at the trailer. So there's quite a few, like old people can't really do head checks. It's a very awkward move, and a lot of people just are taking sort of just a guess at it, and they just go. So there was really good work done by Shane Turner and a few others in New Zealand on the seagull intersection assessment tool, and pretty sure we could actually put that into the resource thing, but it shows you, what situations a seagull may actually perform, but it's not a lot of the time that it's actually a really good treatment. So yeah, I can understand why New Zealand is making the seagull extinct. Okay, what else did we have? So then we had some people talking about raising parts of this intersection. That's interesting. And people talking about raised platforms, raising the intersection. We had people trying to go with the left in, left out, which I do like, because that's simplifies the thing, removes a lot of that turbulence, but I said we can't really do that. So bus priority transit lanes as an exposure, and that's an interesting one, because yes, it actually does link in nicely with safe system principles. Putting people onto a safe form of transport, less vehicles, less exposure, and it is an exposure one. I'm just skimming through these wonderful comments. People trying to get pedestrians separated to change the exposure, and that's good. So talked about utilisation of the drainage facility in one way or another. I'm a big fan of doing that. Now, some people freak out. We'll have pedestrians drown when rains come. Well, no, there's a lot of situations where you use existing structures and facilities, and pedestrians don't go in there if it's starting to fill with water, so that's a good thing. You've got to think holistically about personal safety and these things, so there's enough light and it's attractive. But if you've got existing bridge structures and linking with your shared path network, it's just good use of money. I mean, it is so well aligned with safe system principles, and it removes exposure to crashes. So if you can look to do that, it is a good thing. It's a bit expensive on this one, but you haven't been there and looked and worked out all the details. So I think it's a great thing people are thinking about that. We've got some people thinking about how we would get pedestrians across the intersection safely. I'm going to jump out of people's comments, but again, I thank you for that wonderful input. I'm going to talk to a few things here. So we had this sort of, some people were saying, well, signalise it, and then we talk about the costs and things, and signals seem to be a preference from quite a few people. And signals squarely influence the likelihood of crashes, okay? Now, yes, there's going to be scenarios where there are crashes at lower severity because the signals were there. So, it went orange, and then they decided to brake at the last minute, and then they crashed, but they were lower speed because they're right. But there are going to be many scenarios still where the crashes will be at as high, sometimes even higher severity as it currently is with a passively controlled give way set of signal. Sorry, give way control. So give way sign. So we attribute traffic signals in terms of their risk reduction characteristics to the likelihood and only likelihood. They lessen the chance of a crash happening. Interestingly, when we look at any major metropolitan area, in this case, I did pick Melbourne, but I could have picked Christchurch, Auckland. In outer suburban areas where you've got a bit of speed up on your major roads and just hot-spotted death and serious injury, you see all of these large signalised intersections. In fact, all of the hotspots are. That's interesting, isn't it? So there's something weird going on here, isn't there? Because signals, aren't they like a great form of control? I mean, almost like the ultimate thing you'd get to with an intersection, isn't it? Well, no, it's not. Not from a safety perspective on these high-speed roads. And when I say high speed, I'm talking about 60, 70, 80 kilometre per hour roads. And this is because people run the red lights. And they run it at speed and at bad angles. And if you just do a quick download of your top 100 intersections of death and serious injury, if you have a major metropolitan area, you'll in there, you'll see large signalised intersections dominating your top 100. And what do? We go, oh, well, we'll put a mast arm on there, LED lights, maybe an advanced warning sign. Yeah, everything we're doing there is just trying to get every last drop of likelihood reduction out of the signal, right? We are not addressing the severity of crash, and it is far beyond what the body can handle. And this is a great example of safe system, or in fact, non-safe system here, because we are relying on humans never making mistakes in order for these to operate free of death and serious injury. And that goes against one of the key principles of the safe system, which says that people will make mistakes. Okay, 999,000 of them won't, but the one that does is going to be really bad. Well, when we look at a roundabout, roundabouts are all about the severity of crashes. And why is that? Because people approach a roundabout, they slow down, the angle of crash is better, and all of the incidents happen at far lower speeds and lower transfer of kinetic energy. This is passenger vehicle crashes that I'm talking about. Passenger vehicle to passenger vehicle crashes. But we had to sort of dismiss the roundabout there, didn't we? Because it was just going to cost too much. Now you can look at this one. Obviously, it's not the same site. And you can see it's big, isn't it? It's big. It takes up a lot of land. Why is that? Well, you've got to, you've got to get a big truck to go around here, or a bus to be able to make that turn, or even a U-turn. Got to have a swept path. To do that, it has to be really big. But I wonder, if we need them to be that big. Again, a different road environment. That's not the same as the one we looked at, but that roundabout's pretty small, isn't it? And, well, it's actually just some paint. But why would this provide any road safety benefit? The reason it provides a surprisingly high road safety benefit is because anybody approaching this, well, they don't think that they have ultimate priority. And that's a major win. I mean, this is kind of the UK equivalent of a four-way stop, which, you know, it is disrupting ultimate priority, because as drivers have that continued priority, right, they tune out, they don't look around, they don't slow down, but you can disrupt it in these ways. People get very worried about these smaller roundabouts in terms of how fast people will be going through them. We can dampen speeds down with these things on the approach, and there's lots of great opportunity. But why are roundabouts performing so much better? If we just go back to passenger vehicle crashes, some road safety engineering 101 here. Here are conflict points. These are the points that you can crash. There are far less conflict points at a roundabout, and the conflict points that exist are friendly angles. They're the angles that crashes can happen at, your worst angles. This, good. This, not good. Lots of wallies today. This is the one that, so what happens when people are driving the road network is that we would love them to be alert and compliant and you know, have had a great night's sleep, had their coffee, concentrating really hard on the driving task. The reality is that people drive in all states of consciousness. They have worked a double shift, they're slightly intoxicated, they're thinking about the fight they had with their partner, they're thinking, you know, about the exam that they've got coming up, that they are often just not with it, right? And we can get annoyed at that, and we can say that, hey, you need to be taking this task seriously. The reality is that is being human, right? I was chatting to Bridget Doran, for those who know Bridget, about her PhD on what drivers do and think about during the driving task. And unfortunately, there is a very small percentage of time that it's actually focusing on what is going on in the road network. And that's the ones that she was within her study who were sort of, you know, at least sober and at least, well, you know, generally well rested. So as people are driving along in these varied states of consciousness, if we have a set of traffic signals, a percentage of them will drive straight through it. They won't even notice it was there. There is nothing physically altering in the road environment. The civil infrastructure doesn't change. It continues straight. It just goes. We try to put lots of lights in their eye line and everything like that, but there's a percentage you just miss it. Now, some of you, I'm sure some of you have done it. I mean, I'm sure some of you have driven in all states of consciousness, and you know that when you go, I don't remember the last 5 minutes of drive. It's a bit scary, right? But you drove it, right? And also, some of you will have no doubt gone, did I just run through a red light? Right? You weren't constant, you weren't with it. But that's just, it's not because we're bad people and intentionally doing this. It just happens. But amazingly, when you put physical infrastructure to disrupt that straight driving task, that roundabout, right? They come back to it. They look around. It engages them with the driving task. They come back to reality. They look around. They slow down. We just had huge wins in road safety. We got them to engage at an area that is our spiking risk point, the intersection. Yeah, it's not great that they're driving completely out of it back and forward. We can work on different aspects of that, but it's a huge win. The roundabouts are an amazing road safety feature when we talk about passenger vehicle to passenger vehicle crashes, which are a huge proportion of our intersection crashes in these higher speed road environment areas. And traffic signals are, they help out a little bit in terms of reducing the likelihood of crashes. Well, they help out about 45% compared to a roundabout somewhere around 80%. Reduction in death and serious injury, that is. Interestingly, Professor Jeremy Woolley, when he was doing a major review of National Road Safety Strategy, he said traffic signals are the biggest failure of traffic engineers, which I had a good chuckle at because I think he was being quite provocative. But his intention there was to say that a lot of traffic engineers and a lot of people managing road networks believe that they have done their job by putting a set of traffic signals in. It's sort of the ultimate, and then it's done. And people need to start stopping at that red light. Like, that just pushes all responsibility, all blame back onto the user. And we keep building it. And we keep thinking for some reason this one might be different. And it's not. Now actually, Kathy, have I got time to jump into? I'm leaving the slides, Kathy.
Here we go. Okay, sure. Leave the slides.
Sorry. I want to dig out a memo.
Okay.
Nice story, and I did tell it to another group, and they enjoyed my little story, so I thought I'd do it again. I found it.
It's story time again.
Story time. So this is, let me, this is a memo. I was in Vic Roads, the Victorian Road Authority. I was in the road safety department, and there was like the world's biggest, it wasn't world's biggest, but it was a massive congestion easing program. It's like 15 years ago. It's called Keep Melbourne Moving. And, the traffic engineers had done their, mass amount of modelling and worked out, there's all these spots on the network slowing things down for cars. And, here's this massive program. And what did the program involve? Well, it pretty much involved ripping out roundabouts and replacing with traffic signals, because you can get a little bit more flow through them, and you can control those peak periods a bit better. And there were some other little bits and pieces. Anyway, so all of these project designs were coming in to the road safety department for their official, road safety review, which is where they expected us to look at the, signal phasing, the line marking signs, mast arms, desire lines, and those things, which we did. But we also started, myself and a colleague started putting this memo on the top of the package we'd send back to the region. So it says, the road safety department's analysed this project as increasing crashes as follows. Project life, 20 years. Number of deaths attributed to this project, 2.3. Number of serious injuries attributed to the project, 12.6. Or whatever we calculated of that, which isn't a hard exercise to do. The above trauma is accepted by, and then we left it like that. So I took one of the templates when I went, because I thought, this is important sometimes to boil things down to a simple, all right, if moving a few people through these intersections a couple of seconds quicker every morning is the priority, sign it off. Sign off that we are valuing that over these people's lives. And, well, did we get any back? No. Did we get a call up to the chief executive's office for talk about what the responsibility of a road authority is, yes. But it did disrupt and it did change some things. And I'll show you some of the change that did result. Long effort to get the change to happen, but some things have progressed. Anyway, there you go. Kathy.
Got a new job? Was that
No,
one of
no, I didn't. I did not get a new job as a result of that.
All right. Ken, just quickly though, there's some commentary about how good roundabouts are for motor vehicles, and you've talked about passenger vehicle to passenger vehicle. However, pedestrians and cyclists, they can be much more difficult to navigate and not necessarily safer for those road users.
I agree with a little disclaimer to a degree. Yes, I am very much in this session talking passenger vehicle to passenger vehicle crashes when I talk about roundabouts and their wonderful features. I will talk next session about understanding appropriate intersection treatments based on your movement in place and your one network framework, and thinking about, well, are pedestrians and cyclists going to be, going through here, and how would we, even for more rural intersections, accommodate the occasional cyclist and pedestrian at these roundabouts in order to do that safely? Because I do agree. The reason I'm hesitating is there is actually no evidence that pedestrians fare worse from a safety perspective at roundabouts. There is a little bit for cyclists, but I suspect that that's because nobody's done a study that comprehensively looks at exposure, and that pedestrians just won't cross at roundabouts. And then there's all the societal spin-off badness around people not walking, and people just, if there's a roundabout, they don't walk because they can't cross a roundabout, and all those sorts of issues. So I agree, and I'll show you some wonderful ways to get the best of both worlds, roundabouts and wonderful pedestrian and cycling facilities. So get ready for that next week. Anything else, Kathy?
No, I think that's good, but keep the comments or questions coming in, and probably just a clarification maybe on your memo. There's a comment about don't like the word accept. I think, as in accepting, you were asking your regional director to accept that road trauma, and that's the whole point, that nobody did want to sign off that they would accept that.
Yeah, that's exactly why it's the right word. Because I say, are you going to accept this? And of course they're not. So they have to change something. So yes, it was intentionally used to, I don't know what the word is. To incite change.
Incite anger with you. Tell us about Dutch roundabouts, maybe. Are you going to go to Dutch roundabouts, or are you going to go to some other roundabouts?
I'll go to some Dutch roundabouts.
Okay, great. Thanks.
The Dutch like a turbo roundabout. And because not all roundabouts perform the same. I mean, actually, I'll jump through this quickly because it's a bit of just interest, but it's some safe system aligned thinking with it. Not all roundabouts perform the same. Single lane roundabouts versus double lane roundabouts, and we're starting to see differences in safety performance. Here's an interesting thing. I mean, it's speed, which is always a pretty good proxy for safety performance. You've got in the radius of the roundabout, and you can see that a 2-lane roundabout flow radius is it's just high speed through the roundabout, and it comes down. Turbo roundabouts, interestingly, performing the same as a single lane roundabout, which is a turbo roundabout is a double lane roundabout, but it's got a raised separator. So there's a raised concrete separator on the approach and throughout. So you see a vehicle comes in and they can't straight line it through, and it channelizes, so you don't get those late last minute moves of passenger vehicles. For those talking about cyclists and pedestrians. That's how you cater for them at a roundabout. Pretty awesome. But turbo roundabout's pretty great. They do a wonderful job. You want to turn right, you've got to do that move. There's another turbo. Excuse me. I like this picture because we're seeing some conflict. Look at the angle that's happening. Beautiful. And we know the speeds are going to be low, don't we? We know that white vehicle is coming in, and it's quite a radial roundabout, isn't it? For those who play in roundabout design. So we know speeds will be low. And angle's good, mistakes happening on the road network, and we know it's not going to result in death or serious injury. This one's pretty good. It's another turbo roundabout. And we sort of look at this, and we go, what on earth is this? Well, there was a Dutch engineer we had come over to spend some time with us doing roundabout design for cyclists, actually, how to design roundabouts for cycle safety. And I was showing this Dutch engineer this is in the Netherlands. And I was like, this is just amazing. Like, so I was saying the photo, and he was like, yeah. I said, in Australia and New Zealand, we'd probably have this as a large, high-speed signalised intersection. It might have got grade separated at some point, but it most likely would be a large signalised intersection. And the Dutch engineer was like, just could not fathom that, and said, well, but what about all the death and serious injury? Why would you do that? Like, how could you possibly subject your community to this? And the thing is, they'd rather do this and this massive land take and huge cost and all of this than possibly even consider going with something that we just take as run of the mill. Now, this is signalised, and I suspect when you are, at ground level, it would not be as, confronting as it kind of is. But nobody's going through there fast, and the angles of impacts are going to be better. Anyway, bit of fun for you. But it's interesting to see some concepts now emerging which try to provide as much traffic throughput as possible, but retain some of the features that give us good safe system alignment of roundabouts with these large traffic, traffic intersections. So you can see this one's up through roundabout. Vehicles approaching, they're going to wake up because they've got to navigate something. We get some better angle happening. So this is a concept. This hasn't actually been built yet, but it sort of shows the people are really starting to question large signalised intersections. And it's fun that I'm just super excited now to see so many people talking about raised platforms and raised intersections on that example that we were doing there together. And why is that? Well, because 10 years ago, nobody would say that. Absolutely nobody would, because it was a major arterial, state highway, it's got 29,000 vehicles, it's got freight, it's got buses. You couldn't possibly do vertical deflection on that in people's mind. But now we've evolved and we've moved forward, and we understand some of the European raised platform design, that they're like this. They're not these sharp speed humps as such. They're shallow platforms to wash off appropriate speed. And that's what was proposed at that intersection, because the costs couldn't get in that full-size roundabout, weren't prepared to go with a smaller roundabout. There's, upstream there were signals, downstream there are signals. They had unbalanced flow, so a roundabout wouldn't have performed that well unless you'd metered it and done other things. So they landed on signals, but it was great. They were at that point. They said, well, if we know that signals in our area are presenting a lot of death and serious injury, and we're going to build another set of signals, are we really going to think anything different is going to happen? I said, no. We need to change something up here. And yeah, they went with the raised platforms on these two approaches. They didn't do anything raised over here. Why not? Because these vehicles coming out and going in are not the bullet vehicles. These are the ones that do the damage, right? So you only need to slow them down. Well, these are going to slow down on their own accord. That's for a T intersection like this. If it's crossroad, it's a different story. And what do they design that for? 50 km/h, because that's the right angle vehicle to vehicle impact. Now, they could have looked at pedestrian and gone down to 30. This is where they started to get into this balance. What's the function of this road and a whole lot of other things. So it's not quite there, but it's very well aligned with safe system principles. But the likelihood of crash is down because of the signals. The severity is down because we're actually washing off speed. Vehicles slow down on the approach to this. And here's an awesome picture. I was out there with a colleague. We were doing the post-opening road safety audit of this. And look, we've got a vehicle slowing down on the approach to a green light. Oh, right. This was great. And the traffic ops people, they get angry at this. Like, oh, it's so inefficient. And, you're like, well, if we'd done the roundabout, everybody would have slowed down always, and nobody would have complained about that. Like, it's just that, this is different, and people don't like change and all sorts of typical stuff like that. So it's pretty exciting. And here's another little exciting bit out of it. Some of you may know a term called the dilemma zone. The dilemma zone is a traffic engineering term, which is a point in time and space where a driver is in a dilemma as to whether they put the foot down and go because the orange light has appeared, or they slam on the brakes and stop. And the raised platform as a feature in the intersection just significantly reduces the dilemma zone to a point where almost all drivers in what was previously the dilemma zone stop, which is just another good win. Extra spin-off win. And it's great to see Hamilton City Council putting in some raised signalised intersections down just in sort of outskirts of Hamilton there. Some people will know this one. Thomas Gordonton is the intersection. And that's in and performing beautifully. And this one really made me quite happy. So this is an intersection here, Dalton and Childs Road in Thomastown. It was a roundabout. And in another congestion easing program, 10 or 12 years after that one that I talked about, the roundabout was being removed and replaced with traffic signals. But as part of the process, they had to do a safe system assessment. And the safe system assessment said, you're going to make things worse. Showed that this is not going to be good. And suggested a raised intersection. And that's what went forward. I mean, I'd prefer that to be 30 or 20 even, but that's neither here nor there. I mean, it's a deficiency, and that should be. But nonetheless, we saw roundabout removed, signals, but raised platform to at least ensure that the safety was going to be maintained, if not improved. And that's exciting. Plus, Dalton Road carries about 55,000 vehicles a day, major bus route, heavy vehicle route, major emergency route, like emergency vehicle route, and Charles Road's about 25,000. I mean, these are big roads. So yeah, it's just exciting, and you can see that evolution. So they don't need to do the memo anymore and get everybody all worked up. They can just simply have a system assessment process. People still get worked up. Anyway, lots of design guidance now for you for your raised safety platforms, raised intersections. I still like this 10307 road design note out of the Victorian government. I've had some input into that, but there's some wonderful New Zealanders who put together the Austroads report 642, effectiveness and implementation of race safety platforms. So that's a good one. It's got Hamilton one on the front cover there. So really good stuff there. I think we better have a little quick break, eh?
Yeah, absolutely. Thank you, Ken. And it's interesting what you talk about, that these are relatively new treatments in this space. They haven't been around for decades and decades. They've just been around for the last 8 to 10 years or so.
In Australia.
In Australia.
Yeah.
Sorry. Tell us just before
and New Zealand, of course.
And New Zealand, yeah. Sorry. In our space. How common are signalised roundabouts?
Yeah, so signalising roundabouts is not as common as I'd like it to see it. So signalised roundabouts retain a lot of the benefit. You can encourage more traffic flow. You can get it safety for pedestrians. I'm going to try and find a little bit of space to draw. If you have a roundabout and you have unbalanced flow going on, you can signalise like one leg, and I like to do it often with pedestrian crossing, although it can be problematic depending on how your flow is, or you might just have a splitter island and only do signalise half of it. If you're worried about flow banking up, that's not a pedestrian crossing. Done. All right, let's do that. And then you simply put a loop in there, back down this road at some point. Oh, no, yeah, yes, no. Sorry, I'm all over the place here, Kathy. A loop down that road.
We might all take a break whilst you finish
my drawing. You put a loop down there that triggers these signals when the queuing gets back to a point, right? Down the road. So you go, okay, now the queue's X amount, make that red. So then these vehicles off they go to where they need to go, and then you drop it back. So you're it's called metering a roundabout.
Okay.
And then you can sort of meter one and then another and then another, and then you can extend the life from a traffic perspective significantly. But as I talked about, you can also signalise the whole thing with pedestrian crossings and everything. Just leave your roundabout there. You have to phase it in a certain way and some other tricks, but it certainly can be done. But it is not like a majorly common treatment. Mm-hmm. But I think really good raised safety platforms on signalised intersections is a pretty outstanding safety feature these days.
Okay, great. Thank you. Any other comments or questions, please do keep them coming in. Otherwise, we'll have, 3-4 minute break, enough time to get a couple
3-minute break. because we've got to give people an assignment at the end.
Yeah. Yeah, that's right. Okay, thanks. Now, Ken, I've popped a couple of these resources into the learning management system into module 2, just for everyone. So there's this race safety platform Austroads document, as well as a great webinar that Austroads did maybe a year or two ago. I don't know, I was tracking the COVID years, which is, yeah, really good webinar, answers a lot of the concerns around them and that sort of thing as well. So it's good extra homework viewing for people.
Thanks, Kathy. Okay.
Maybe we'll just get a bit of a thumbs up if people are back. Just something to, they can wave at. No. Yeah, there we go. There's at least 1, 2.
If they're trying to look for, now they're raising their hand. Kathy, your cousin also.
Oh, no, yeah, that's okay. That's all right. No, that's good. It's perfect. Yeah, you're back. People are back. That's good. Thank you.
Okay. I want to just give this example. I won't spend long on it. So this is an intersection, 2 high-speed roads, rural area. And this one had a crash history, and I really wanted to, fix it. This is a telecommunication exchange, and they wanted to put a roundabout in. They discovered, it's going to cost an absolute bomb because, the roundabout's going to need to take up this huge area, and then they want to do reverse curves on the approach to the roundabout. That's a very exaggerated reverse curve, but all these. It's just going to be this huge, massive land take, and the cost was just blowing out. Moving this thing in its own right was like $1 million, and buying all the land up, and yeah. Anyway, so they said, we'll just put in some right turn lanes and some warning signs. But again, the safe system assessment sort of saying, well, that's going to improve and reduce the likelihood of crash, but are you addressing the severity of crash? And then so, back to the drawing board, and what else could we do? So that's the intersection there, high speed. That's the arterial road crashes, but they really looked at it and they said, well, let's go with that smaller roundabout. Let's go with something a lot smaller and see how that performs. And so this was a compact roundabout, and worried about the speed people would approach it and go through it. So you can see there that again, they've used raised platforms to slow vehicles down on the approach. Very tiny little roundabout and a big concrete apron around it. Bigger concrete apron around it, raised the area. I presented this at the recent Australasian Road Safety Conference in Christchurch there, as we've written a technical design guidance document for compact roundabouts. And yeah, so you can see that there, but here's the roundabout, see shallowish raised platform, first of all, which kind of replicates the first reverse curve to slow people down on the approach to the roundabout, raising up the next one a bit sharper, very small little roundabout, large vehicles sort of sweep over this. They mount their island. There's a little bit of widening out here, with a concrete apron there too as well. So I put it up for those who are designers. It's fascinating, but also for those not, it's pretty interesting in the sense that people are now pushing and saying, well, it's not acceptable just to do right turn lanes and hope to reduce the likelihood a bit. We've got to start really addressing the severity of these crashes. Quick quiz, Kathy, and I see maybe questions and hands being raised. It's all happening in the background, so hopefully
it always is. So tell us the location and cost, please. We want the stats. Go.
Yeah. So I think a full-size roundabout was going to be $7.5 million or something like that. and that one came in at a bit under 4. So, significant saving. It was about half the cost. And location, that is at a place called Lance Creek in Victoria, and I can send anybody that would like the detailed design set of that.
Yeah, that'll be good. Was most of the cost because of land take, or was it because it was kind of the first of its kind?
There was a bit of first of its kind extra costs, but there was a little bit of land acquisition and then pavement, civil, lighting, all of that usual stuff.
Yeah, so we're getting a lot of requests for design plans. Are you writing that down? I don't think I have them, Ken.
Okay, can you email me, please?
Yeah, all right, no worries. I'll pop them into the learning management system as soon as we get them through. Sorry, and there was a quiz. Yep, okay, let's do it.
So quiz question, which should have popped up on your screen, true or false? Traffic signals are not safe system. True, false, or unintelligible question, meaning I don't have enough information to answer that, or what are you talking about? That's like, Ken, that's a ridiculous question, is the last one.
All right, I think I'm going to do this. Is very, very interesting results.
Wow.
I know. I have not seen one like this before.
Well, lucky you asked the question.
Yeah.
So I suppose unintelligible questions probably a pretty good starting spot, because first of all, we don't talk about safe system in a binary sense. That's safe system, that's not safe system. Well, it's a spectrum, aligns highly with safe system principles, not so much. So that's one thing. First of all, I gave you no, and then second of all, I gave you no context in this, did I? But people who said true, maybe your context that you were thinking about were high-speed road scenarios. People who said false maybe were thinking, well, it's not the signals, it's the signals in their context. So that's not true. So how about we give everybody the benefit of the doubt and say everybody's correct? But why did I put that question in? I have had some people come out of this course and say, you can't do traffic signals. Like, they're not safe systems. And I'm like, whoa, 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 whoa. Context. Let's think about all of that. So anyway, that was the only reason for it. Thanks for getting involved, though. All right, Kathy, I'm going to just go quickly so you give you enough time to introduce this exercise, because it's exciting and fun. We've been talking about intersection. Passenger vehicle to passenger vehicle crashes at intersections predominantly. And as I said, we'll talk about pedestrians and cyclists and motorcyclists next session. But lane departure in that mid-block location and vehicles leaving the road. We've got a big, long, straight road like this, relatively straight, and there's lots and lots of this across New Zealand. Maybe just type in the chat, what crash types do you think might be occurring there? I say it's 4,000 vehicles a day, 100 kilometre per hour, sealed shoulder, separation by white line. What do we think? Yep. Look at that. So we know the issue, don't we? Everybody's on it. People are running off the road or they're having head-on crashes. And yeah, the mechanism for why is often that they've fallen asleep and the like, or distracted by something or the like. But it is just a lot of people leaving their lane departure, as somebody said in there. It's a good description of either the runoff road or head-on crashes. They happen at a speed that is just absolutely unsurvivable. And so we see a lot of the New Zealand network that looks like this, operating at 100 kilometres per hour. And if that vehicle is out of its lane, they won't survive that. And they hit that truck. If that vehicle goes off the road, they're unlikely to survive that. Depends exactly whether they roll or hit a specific object or the like. Going to be very bad. We talked about the speed of the ANCAP crash test. It's gone up from that 29 kilometre per hour one, which I'm showing in the video, to 32 kilometres per hour. But the speed we travel with fixed hazards. Let's have a look at this one. Now, this is going to be a bit more graphic. 60 kilometre per hour. This is an estimated 60 kilometre per hour impact with a fixed hazard. I have to press on it, do I? That just shows the absolute violence of these crashes. About 60 kilometres per hour. The forces are just astronomical, and it's all concentrated into that point source. So if we remove all these trees and power poles and everything like that, we lessen the risk, but we don't eliminate it. Plus, it's becoming near impossible to do that, which would be a good thing. We don't want to cut all the trees down, and we don't, well, removing the power poles would be a good thing, I think, and the like. But rollover crashes start to become a factor into it. So as we clear more area on roadside, we start to see the clearing area free of hazards, clear zone, and we see runoff road crashes coming down, rollover starting to increase, because vehicles have this area to yaw. So what happens in a runoff road crash? People fall asleep, they leave the road, or they've been distracted by something, they're not looking, they leave the road, they wake up and they yank the wheel back. They may hit an object as they're doing that, or they might overcorrect, or they might start rolling. And the more space there is, the more chance they're going to roll. Now, rollovers are a less severe crash, but they certainly have some pretty significant spinal injuries, head injuries, and deaths do occur as well. So creating these cleared areas free of hazards, I mean, you just have to keep clearing and have to compact the roadside to a level that's pretty much a shoulder in order to start to get to what we would call well-aligned safe system. But we're talking down here somewhere at 25 plus meters. It sort of continues to go down a little bit. I'll jump through that. So clear zones, and using this idea of a clear zone, is not necessarily a safe place to be. People go beyond that, they roll over with it. So there was a time when clear zones were just the best we had. Like, you leave the road, you want a cleared area to have a chance. Well, it's probably right for about the first 4 to 5 meters, but after that, it's not. And so if we're building new roads or the like, 2 years ago, Austroads would have told you to build it pretty much like this. Well, probably not have those there, but a wide sort of median area, shoulder. Well, I wouldn't have truck strips, but We wouldn't have truck rumble strips, but they're just a trial that we were doing on one of the roads. Sorry. But essentially, you'd have all these fixed hazards at whatever you calculated as your clear zone, 9 meters, 12 meters there, and this big, calculated clear area in the middle. We know heaps of people run off the road, they hit those trees, they get across the other carriageway, they go all the way to the other trees, they head-on crash. So the new Australian Guide to Road Design Part 6 is more progressive in this sense, and I'm not going to go into the details of that, but what we're looking at for highly aligned safe system roads in these rural high-speed environments, big state highway connecting major areas, are essentially full containment, bumper bowling of roads, barriers just the full way. So we say, well, people are going to leave this lane and leave this area, and they should hit a barrier. It's actually safer to have that barrier at 4 to 6 meters than to have a cleared area of like 20 meters. Now, people find that a bit interesting, but that just shows how awesome barrier systems have become in the last decade. Flexible barrier systems are just amazing. They cost a bit of money, but they're pretty amazing. Yeah, we've got to think about how we implement it and all of those particular design specifics. Think about communities' reaction to it, and there's lots to work with. We had rolled out a lot of barrier at about this offset, which caused a lot of trouble. Not because it wasn't a great road safety intervention, it was just that people really did not like having to break down and be stuck in these positions. So we got some learnings out of that. I'll probably finish on this one, Kathy, to give us time to talk a little bit more about the thing, and I might bring up a few other things if we have time as well. This is a crash that happened in Mildura, like country town / city. It's 2 a.m, 4 young male passengers in an old Ford with like maybe 1 star of safety rating if you're lucky. And they crashed into a power pole at 92 kilometers an hour, was estimated in the forensic analysis report. Now, in most, almost always, you would say, yeah, a lot of them will be killed or seriously injured, but they all got out of it with non-life-threatening injuries. Some of them nothing, but a couple of them, minor injuries. That's just absolutely amazing. And the why that happened, well, one of the reasons the forensic investigation says is due to the fact that this raptor cushion was on the power pole. Now, I'm not saying that raptor cushions are, not selling those or anything, but the concept is wonderful in the sense that a raptor cushion sort of does cushion the impact, so that's a good thing. But it also rotates, and that's a really important thing because it's thinking about energy management. As a vehicle leaves the road, hits this, it tries to deflect the vehicle off by rotating, deflect them away from the pole, which is just a wonderful kinetic energy management technique. You've got the thing that's going to push kinetic energy straight into the human, but if you can move them along a bit, wash off some more speed, it becomes a really, really great or a much better outcome. So that to me is really, an important aspect of this is that we really need to get ourselves in the headspace of kinetic energy management. Thinking always about what is there in the road environment that is going to transfer energy to the human. What is the inherent energy in the system? And is it tolerable for the crashes that we expect to happen? So that's how I now look at a road network. So I've been road safety auditing for 20 years or so. And I used to really hone in on that. What is going to cause a crash? See-through effects, dynamic visual obstruction, people not, or, pedestrian desire lines, over here. And I still look at all of that. But this other layer that is really dominant now is that potential energy transfer. Okay, so I'm just thinking, I've got pedestrians and I've got vehicles, and the vehicles are going X speed. They're going to hit a pedestrian, right? Even if we get the desire line right, we put a facility on the desire line, somebody's going to hit somebody. What speed is that happening? What's the energy transfer? Is that tolerable? Okay, an intersection. And you're thinking about, there's not enough advanced warning of this intersection. Can you see it? Do we have approach sight distance? Do we have sight distance to the thing? All of that is important in the likelihood of crashes. But then crash is now going to happen. What's the speed? What's the angle? What's the mass of the vehicle? Just simple kinetic energy. And that's going to get transferred. And does that fit within our tolerable limits? So we're in the game of energy analysis now, kinetic energy analysis, as well as thinking about trying to stop crashes happening. I don't think we've got another quiz, actually, or do we?
No, but it was quite funny earlier. Keegan suggested we bubble wrap poles from now on, and I guess a raptor cushion kind of is a big bubble wrap around a pole, isn't it?
Well, it kind of is. It's that and the sorry, am I still sharing my screen? No, I'm not.
No.
It's kind of bubble wrap plus that. I use the analogy of the of martial arts punch. They tell you to deflect the energy of the punch, so it doesn't. Yeah. You think I have ever done martial arts in my life, Kathy? No.
I love
I watched The Karate Kid.
Well, that's enough, isn't it? You're an expert. Tell us a little bit before the raptor cushion, though. There was a question about how do you cater for breakdown safety? So this was, I think you were showing. I've lost it. Do you remember what you were showing?
I do. I was showing barrier systems continuous.
Yes.
And then I showed a photo of a car that was broken down very much in the lane. So barrier design, I mean, you're optimal for continuous barrier systems is 4 to 6 meter offset. So a vehicle has the ability to get out of a running lane. There's a really awkward lane width around 2.5, which kind of looks like the vehicle can get out of the lane, and then they pull over and they're kind of not, and it's just bad. So, and then you can go really sort of 1 meter where it's obvious they can't, but you have to be providing breakdown bays and points for vehicles to be able to do that. So, barrier design's quite an interesting topic. I mean, my colleague Jamie and I run a 3-day barrier design course because there's a lot to think about, which barrier type, how you do your end terminals, how do you cater for these breaks, what length of barriers, what radius curve, how do you do your civil works, how do you, there's surprising amount between, some surprising amount in it. And things, I think there's a question coming in there, what distance between these points? Well, yeah, it's not, I mean, there's nobody's absolutely documented you need them at this sort of spacing. So, because it depends, how much of your system are you running close to edge line, and do you have areas? Yeah, I mean, I wouldn't be looking at more than sort of 500 meters to 1 kilometer of area you couldn't pull over whatsoever safely out of these areas, but it's a bit of case by case.
Another question in in the world of autonomous transport choices, do we have zero need for safe system principles?
Uh,
Can you give us an answer in under? Well, let's all sit down and have a conversation.
I think the principles are still relevant. It's just that the autonomous vehicles are going to align well with those principles. So, because if we're thinking about ensuring that we have a system designed for humans to make mistakes, and you've taken humans out of decision making, humans can continue to make mistakes, and the vehicles are the ones making decisions and in control. So that's big tick on that aspect. We do want to still think about, I suppose, situations where conflict could still exist. So I think to absolutely, completely eliminate all the risk of crash out there is going to be a challenging thing to do. So let me give you an example. There's going to continue in the foreseeable future, and my lifetime, my kids' lifetime, that even if the vehicles are autonomous, they are interacting with areas where there are pedestrians and the like. There has to, dropping off, So you're going to have to, with the physics of this, think about if a vehicle's driving along and there's potential for pedestrians in a general area to step out, right? You've either got a choice of going so slowly that vehicle can stop, which is ideal, or so slowly that if this did happen to be a crash, that we were within these tolerable limits that we've set. Now, so I just think there'll be this murky sort of grey area as we evolve that. But we're already seeing that, with the automated vehicles sort of running around the system at the moment, the Teslas and the like. I mean, they're making calls that they are not, eliminating crashes in their predictions and the like. They're trying to get them within tolerable limits and do the absolute best they can to stop them happening. But, it's an interesting one, because you look at like aviation, and they don't play in energy management. Like your plane crashes, you're all dead, right? So they have just gone so hard at likelihood of crash that they just have so many layers of protection on that. We still see occasional. So there is the chance that we do in the end get into that with vehicle transport, that we have gone so hard at likelihood. But the transition over the next 50 years or whatever it is, we're not, people just are not willing to accept, safety briefing every time you get in the car, these, just think about all of the safety stuff that goes into planes and overlaying that onto a vehicle. Well, certainly none of us would be allowed to drive. That would be the first thing. You'd have to be tested and sort of on a good. All right, I'm going to make everybody do some work. Okay. Oh, whoops. Hold on. Sorry about that. Okay, so here we are now. A bunch of things in there, and we'll pop in there those Lance Creek roundabout designs as well. That race safety platforms, this is a road design note from Victoria on that, the Austroads webinar, and then also a road design note on the compact roundabouts in rural high-speed environments. Again, that's another Victorian document.
So you do have another quick quiz this time around. So thanks for jumping on and doing the one for module 1. And your assignment is a very quick assignment. And this is all about making sure that you have a grasp on what is exposure, likelihood, and severity. So what you do is you jump into the module 2 assignment and you open up this PDF. And there it is there. And now it's a fillable PDF. So what you do is just click into the spaces here that are highlighted in blue, and you just type away in there, save, and then upload that document. So let's start with what we want you to do is select an intersection, any intersection. It could be right outside your window now, at home, at work, anyone, or a random one. And you fill in the information below. You don't need to actually physically go to that particular intersection. You can do it via Street View or do it via your memory. And basically what we're looking for you to do is tell us what factors increase exposure to crashes. And there's some examples in there. Factors that increase likelihood and severity. And then you're going to have a think about what is one change that you could do to reduce the impact of those 3 things. So in here, you pop in your name. Amazing. You spell your name. And then you pop in the link to the intersection on Street View. So you just pop it in there so we can actually have a look at it. And then you just start typing away in here. So factors that increase influence exposure. And so we're only looking for a couple here. So minimum of 1 and maximum of 3. So you don't need to write, pages and pages and maybe something that you've written to your local council about or anything like that. Just really a handful of things here about exposure, likelihood, and severity. And then what's one thing that you could do to reduce the impact? So just one thing. So what are we talking about here, Ken? 10, 15 minutes, maybe even 5?
Well, yeah, it could be done quicker, but maybe, 10, 15 minutes is probably right. But I mean, thinking about what is exposure? Well, exposure is about the numbers, isn't it? The number of pedestrians, the number of cyclists, the number of motorcycles, the number of cars. What's influencing that? Okay, what's influencing that number? And then the likelihood. Well, what's influencing the chance people crash? Is it not clear that there's an intersection coming up? Are there bad sight lines? Is the lighting bad? Is there a see-through effect? Is the pavement surface bad? And then what's the severity? Well, severity we've talked about, like it's speed, it's angle, it's vulnerability of the users involved in this incident. And then, what could we change around those? Well, changing something to change the exposure would have to change the number of vehicles or the number of pedestrians or the number of cyclists or the number of motorcyclists being exposed to the crashes at that intersection. So that would have to, I won't give too many clues away, but, you'd have to eliminate something or the like, and likelihood and severity. So hopefully it doesn't take too long, because we're not asking you to give us huge amounts of detail, just a few dot points, and show us that you understand that categorization. Have a good little look at the intersection. We'll have a look at it as well. And then at the start of next session, actually, Kathy, we'll get somebody, if somebody wants to volunteer to talk us through their intersection, we'll give them the ability to unmute themselves and they can talk us through how they thought about exposure and likelihood and severity.
Excellent. So you just, once you're done, you save it and you just add the submission here. If you can, please get it done before the start of next session. As Ken said, we'll ask someone to talk through it. And then it really sets you up for your next assignment, which will be your actual site visit one, where we do get you to go out to a site. Any questions or comments or anything else?
I'll show, while we think of that, I'll just show something, bit of fun for a Friday. we put up safe system snippets, we call it. We try and get all the engineers. This is on LinkedIn. Get all the engineers to come up with little cartoon ideas. This is today's. So you've got the road there, and then.
Are we going to ask people what they think the punchline is?
No, we'll ask people whether they
think it's
get
funny.
it. Give us is there a thumbs down option on the chat?
No, conveniently there isn't a thumbs down option. There's a shocked face. Yeah, that one. There you go. There's that one.
That's oh God. People don't like. Somebody's laughing. See?
Yeah. One. You got 33%.
I think some people are probably going on and get it.
Oh,
sweat the
Leslie, you're gonna
prize, definitely
for
prize.
Leslie. Oh, okay. So hang on. Is this us just getting new material?
yeah. Give us all your puns. We better let them go and do their assignment. It's Friday.
Do you have to be Australian to get it? Yeah, I'm sorry. Sorry.
Probably. So
all right. Yes.
You take a road core. Anybody? No, you do a core sample of a road and you test its strength. Understand how your pavement's performing.
Good one. Okay. Have a great weekend, everybody, and we'll catch you next week. Thanks. Bye.